The best part about this drone is that it is programmable, which means using an SDK, we can control the movement of the drone and apply computer vision techniques without any external wiring. That's right, everything will be done over the Wi-Fi and you do not need even a router for it. In fact, they have added 2 antennas which will allow stable video transmission. The total flight time for this drone is about 13 minutes and the flight distance is about 100 meters with the top speed at 8 meters per second. When getting the drone, you have multiple options. The first one is regular pack and the second one is jumbo pack. There are also 2 types of tele drones. One is regular and the other one is EDU, which is the educational. This course is compatible with both types of drones. If you get the regular pack, it will come with a single battery, extra propellers and the propeller guards. The charging would be done connecting a USB cable directly to the drone. On the other hand, if you get the Tele Jumbo pack, then you will get everything as before, plus 2 extra batteries and a 3-slot battery charging hub. The Jumbo pack is much better for programming because with 3 batteries you can do a lot more testing, and while you are using one battery, you can charge the other one so that you do not have any delays. So first we are going to go to App Store or Play Store and we are going to search for Telo. Now once we find it, we are going to install and open it up. Now the first thing we will do here is to connect the Telo device. So we need to turn it on. You will see the lights, and once they stop blinking with all these different colors, it means it's ready. And there you go. So now it's blinking and it is only one color, so it means it's ready. So we can go to our app and we can click on Connect Telo, and then we are going to go and connect to our Wi-Fi. So here we will connect to the Telo. Once that is done, we will go back. Now we can see the live stream from our Telo device. So here you can see the live stream, and now it means that it is running. So once you have the Telo working, you will go to Settings and you will go to More, and here you have to make sure that your firmware is up to date. So here you will see firmware version and you have to click on Update. So it needs to download first, so you will have to connect your Wi-Fi again. You will have to remove the Wi-Fi of the Telo, and you will, and then once it's downloaded, you will go back and upload it to the Telo device by connecting it again. So here you can see it's already the latest firmware. If it's not the latest, it will allow you to download, and once it's downloaded, you can upload it to the Telo drone. Once everything is set, we are going to try to run it to see everything works fine. So we will click on the takeoff button and we will slide to take off. And now you can see the drone is flying, so we can go forward, we can go backwards, we can rotate back, and then we can go up, and then we can go down. So I think I am about to hit my sofa, so I better get back. Now one thing you have to note here is that even though this is okay, we have 2 options here: tap to land and then hand landing. So most of the times when you're programming, you will be working with tap to land. Okay, so I want to mention here one thing which is very important. Even though this is an indoor drone and it is very suitable for indoor flying, you have to be precautious when you are running this drone. So It has a lot of safety features, but still you have to take care, especially of your surrounding. You have to be mindful of where others are, and you have to be mindful of where you are so that nobody gets hurt. So once this is done, we can go to the installations on our computer and we can start programming this drone.
You want to be an IT pro, so you must have all of these tools: remote monitoring management, remote access,
To program this drone, we are going to use the Python programming language. Now, to do this, we are going to first install Python, and then we are going to use an IDE, which is an integrated development environment, to actually write our code. So we will first go to python.org, and over here we will go to the download section, and you can download the latest version, or my recommendation is to download the 3.7.6. So that is the most stable version that I have found to work well. So you can go to all releases, and over here you can find 3.7.6. So you can download this, and then you can go to the PyCharm download section. Here you can see you have for Windows, you have for Mac, you have for Linux, and here you can download the community version, which is free and open source. Now, if you want to understand the IDE a little bit more, you can think of it like a notepad but with more functionality. So whenever you are writing the code, it will tell you where you are making mistakes, it will help you debug the code, and overall it has much more functionality than a regular notepad. So this is why we need the IDE. So one of the most famous IDEs for Python is PyCharm, so that's why we will be using this. Now the thing is that I have already installed both of these things on my computer, so I'm not going to do that again, but I have the footage from one of my previous courses, which was about OpenCV Python course. So it follows exactly the same procedure. So I will show the footage of that right now, and you can follow the same steps. The only difference will be that when you are naming your project in PyCharm, name it something like Tello course or Tello programming course or something like that. So let's start with the installations. First, we will go to python.org and we will go to the downloads section. Here we are not going to download the latest version. Instead, we are going to download 3.7.6, as this works well with OpenCV. So we will click on download, and then we will head on to the Windows version. Now, if you have Mac, you can download the Mac version as well. Once the download is complete, we will install. Make sure to add Python 3.7 to the path. So once the installation is done, we will close the dialog and head on to PyCharm. So we will head on to its download section and we will download the community version as it is free. Once the download is complete, we will run the installation file. Here we will associate the .py files to PyCharm, and we will also add launchers directly to the path. Next, we will restart the computer and run PyCharm. So now we are going to create our new project. Here, before we start the project, we will look into the project interpreter. Now this has to be 3.7. So if it's automatically detected, then we are good to go. So let's write down OpenCV Python and hit create. So now this is the PyCharm environment. Over here we have the area where we will write the code, and on the left hand side we have the project files and the project folders. So once the installations are complete, we are going to create our project. Now I have named it Tello course. So it will come with this main.py file. We can write in this file, or we are going to create a new one in which we will store all our code. So we can delete this one. We can right click and we can go to new and then Python file, and here we can say basic movements. Now to actually program the Tello, we need its library. So to install that, we will go to file, we will go to settings, and then we will go to the project, then the project interpreter, and then we will add. Here we are going to write DGI Tello. And here you will see that we have the DGI Tello Py library. So we are going to click on that and we will hit install. Now while this is installing, let's have a look at who actually created this library. So let's go to the link, and this is the guy. His name is Damia Phonitis. He's the one who created this DGI Tello wrapper, which is the wrapper for the original DGI Tello SDK. So what this does is it makes it a little more easier to communicate with the Tello and to command all of these different things and to perform different tasks. So there is a documentation for it as well. This is an example. So you have to import the library, and then you have to say connect. You can say move left, move right, move forward, and you can give it some values. So a big thanks to the guy who actually built it and all the contributors who have contributed to this GitHub repo and have made it easy for us to use the Tello library. And the license for this is MIT. So this basically allows you to use it commercially. You can modify, you can distribute, but you have to make sure that you include this in the distribution. So this is the license. If you are distributing, you have to add this to the license as well. Okay, so that being said, let's go back, and now you can see it's already installed. Now another library we will be needing later on is the OpenCV library, so we can install it now. So it's called OpenCV Python. We can click on that and we can hit install, and this will install both of these. And now you can see we have all these new libraries that we did not have before. So we can hit OK. And now we can go on to our coding, and first of all we are going to import our library. So here we will write from DGI Tello Py import Tello, and then we will be needing the time as well. So we will write from time import sleep. So we want to add some delays between each command. So that is why we need this. So to connect to our Tello is very simple. All we have to do is we have to create a Tello object. So you can call it anything. I like to call it me. So me is equals to Tello.Tello, Tello, and this will create our Tello object. And now we can simply write me.connect. And this is how simple it is. You have to just write me.connect, and it will take care of all the IP address and all the communication part for you. All you have to do is you have to run this. And to make sure that it is running properly, we will print out the battery. So how much battery do we have on our drone? So we can write here me.gets battery underscore battery. So there you go. And if you are wondering where am I getting all these functions from, so you can click on control and then you can left click on your mouse, and this will take you to all the functions that you have available. So you have get height, get temperature, get altitude. You have all these different things that you can use. Okay, so that being said, actually let me show you more. You have flip left, You have move back. You have to give the X value. The X value is basically in centimeters. So this is 20 centimeters to 500 centimeters. You have move forward, move right, but we are not going to use these because this is very simple, and you can use this in one of the third-party apps as well that move forward for 10 centimeters, not 10 actually, let's say half a meter, then move half a meter to the left, then rotate 90 degrees. All this stuff you can do with third-party libraries. What we will be doing is we will be using the RC command, and I will show you later on what that does. But before we go there, let's run this and see what happens. So we will right click this and we will hit run. But before we do that, we have to make sure that the Tello is connected to your Wi-Fi. So we will turn on the Tello drone and then we will go to Wi-Fi and connect. So I have turned on the drone right now, and then we will go to the Wi-Fi settings, and here we should have the Tello drone pop up. There you go. So now it's connected. I have pressed automatically connect. That's why it connected automatically. So once that is done, we can go back and we can right click and run basic movements. So if we run that, we get the response. First of all, we connected, so we got the response okay. And then we asked for the battery, so we got the response as 61. So right now the battery of my drone is 61%. Okay, that being said, now we need to see how we can control our drone. So as I mentioned before, you can simply write, for example, go forward. So if you wanted to go forward, you can write me dot go. Is it go forward or is it just forward? Move forward. So it is me dot move forward. So again, all these functions, you can read about them. So it tells you Tello fly forward with distance X centimeters. So you have to give a distance here. So you can write here, go forward, for example, 30 centimeters. And then you can write 50 centimeters and so on. But we don't want to do that. What we want to do is we want to control the speed. So as we discussed in the introduction, the drone can translate in 3 directions and it can rotate in 1 direction. So we want to control that. So we will write here me dot send underscore RC control, and inside that we are going to give in the 4 figures that we were discussing. So first of all, as you can see here, it says left right velocity. So let's say this is 0, and then it will say forwards and backwards. Let's say that is 0 as well. Then we have up and down. Let's put it as 0. And then we have the yaw velocity, which means how much it wants to rotate. So all these speeds we have, and if we click on it, and if we go there, you can see here, this is the left right velocity. We have forward, backwards, up and down, and yaw velocity. So all of these we can use from -100 to 100. So if we want to go forward, we will write, for example, 50, it will go forward. We will write -50, it will go backwards with half the speed. So we can go back here and let's write here, let's go forward 50. Then we will give it a delay. So we will write here sleep for 2 seconds. And then we are going to tell it to land. So we will say me dot land. Now, one thing that I did not write earlier was the takeoff. So before we actually send the command, we have to make sure we are asking our drone to take off. So we will write here me dot take off, and then we can send our command, then we can sleep, and then we can land. Now, if you want to land properly, and if you don't want the drone to be going forward while it's landing, then you have to repeat this and you have to write 0 over here as well. Otherwise, the drone, when it's landing, it will be going forward as well. So first we will stop it completely and then we will ask it to land. So it will land like a helicopter rather than an airplane. So let's try this out and see what happens. So as you saw, it took off, it went forward for 2 seconds at the speed of 50 and then it landed. So now we can move the drone towards the right as well. So we can copy this, and as we know, the first one is basically left and right. So we can change this to, let's say, 30, and let's see what happens. So as you saw, the drone first took off, it went forward for 2 seconds, then it went towards the right side for 2 seconds, and then it landed. So if we write here -30, it will go towards the left. If we write here -50, it will go backwards. So this is the basic idea. And if we want to rotate, we can rotate it. For example, we can say over here, we can say 30. And let's try this out, what happens. So as you saw, the drone first went forward and then it took a right turn. So this time it is in the yaw, not actually the right side, and then it landed. So these are the basic movements that we can control. We can control up and down, left and right, forwards and backwards, and we can control the yaw. If you like the video so far, give it a thumbs up and don't forget to subscribe. So now we are going to learn how to capture image from our drone so that we can process it and do lots of different experiments on it. So we will go to our Tello course and we will create a new file, and this file we will call it image capture. And the easiest thing to do is just to copy the standard, you can call this the boilerplate for the Tello drone. You can copy that, and now we can continue. Image acquisition part is not that hard. What we have to do is we have to write me.stream, and we will turn this stream on. So this stream will give us all the frames one by one and we can process them. Now because it is a continuous number of frames, we have to use a while loop. So we will write while true, and here we are going to write that our image is equals to me.getFrame, get underscore frame underscore read, and then we are going to write dot frame. So this will give us the individual image coming from the Tello drone. And now what we can do is we can resize this image if we want to process it faster. So to do that, we need to import our OpenCV library. So we can remove this. This time we are not going to use it. So we can write here import CV2, import CV2, and at the bottom here we are going to write image is equals to cv2.resize, and then we are going to give in our source image, which is img, and then we have to give the size we want to resize it to. For example, we can say 360 by 240. So we are keeping it small, the size of the frame, so that it is faster. So we can format this, and then we can write here cv2.imshow. So this is so that we create a window to display this result. So we will write here imshow, and then we will write here image, and we will say this is the name of the window, and then what do we want to display? We want to display img. So this is the idea, and then we are going to write cv2.waitKey. Now we are writing a wait key because if we don't write this, the frame will shut down before we can actually see it. So we have to give it a delay. So we are giving it a delay of 1 millisecond. So this should work well. And actually, let's do one thing. Let's remove this for now. And let's try it without the resize, and then we will try it with the resize. So let's right click on image capture. Now again, we have to make sure that the Tello drone is connected. Now it has already turned off for me because I didn't turn it on for a while, or I didn't use it for a while. So let's wait for it to connect. Okay, so now that it is connected, let's go to image capture, right click it, and we will run the image capture. So we have the 40% battery left. For image capture, it should not be a problem, and there you go. So this is the stream coming from my drone at this point. You can see, there you go. So right now it's 1280 by 720, and what we can do is, if we resize this, it will become quite smaller. So there you go. So now it's much smaller, and you will get some warnings here. Don't worry about these. As long as you're getting the frames, it's fine, and you will see a delay in the frames. Now this is because of the transfer, and this is because of the viewing. In reality, this delay is not that much, but because we are viewing it, we are continuously trying to perform all the graphical computations. That's why it's giving us this delay. So normally we will keep it at this size so that the processing is a little bit easier, and it will be a little bit faster with all the different functions that we use. So now we are going to use our keyboard to actually fly the drone. To do this, we need to get the commands of the keyboard first, and then we can implement it with our basic movements, and we can run them together. So to do this, we are going to create a new module called key press module. So a module is basically a piece of code that can run individually, and it can run from another script as well. So if another script wants to use its functions, it can do that as well. So we will create our module. We will write it as key press module, and we are going to use Pygame to actually get the commands from our keyboard. So we are going to import Pygame. Now the thing is that it has already been installed by default. So here you can see when we installed the other libraries, Pygame was also installed. If it's not there, of course you can go to add, and you can write here Pygame, and you can install that. So we will write here import Pygame, and then we will initialize a window for our Pygame. So initially, the idea of this library is to create different games. So whenever you want to detect a key press, it has to be within a game window. So we need to create that window. So we will create a new function called init. We are going to initialize our Pygame dot init, and we will write that our window is equals to Pygame dot display dot set mode, and we are going to give in our size. So this size can be anything that you want. So let's say 400 by 400. And then we are just going to call this function. So let's call it here. So we are going to, whenever you are creating a module, you will write if double underscore name is equals to main. Now this just means that if I'm running this file as the main file, then do this. Otherwise, no need to do this. So we will write here init. So let's see if that works. I have to write double equals. Okay, so let's run this. and there you go. So you saw that this window came up and it went away. So what we can do is we can initialize, and then we will update our window and it will stay, but for now we will move on. So what we need to do is we need to get the key press, and to do that we are going to write, by the way, you don't have to understand this whole part. You can think of this as just a function to get the key presses. So if you don't want to get into the details, you can skip this part as well, but it is recommended that you understand how we are getting the key press. So we will write here, for example, get key. This will be our function that we will call from a different script, and when we are calling the get key function, we can, for example, write here the key name. So we want the left key, we want A, we want S, whatever key we want, we can write here. So we are going to have a final answer, so we will call this and we will write it as false. So by default it will be false, and we are going to return this answer. So if the key is pressed, it will return true. If it's not pressed, it will return false. Now, without going into too much detail, we are going to write a few lines of code. We will create a for loop and we will check the events. So we are getting all the events and we are not specifically doing anything with them, so we will just pass. But then we are going to create our input. So we will say key input is equals to, now to actually check whether it's true or false, it has to go in a certain format. So we need to create that format. So here we are going to write pygame dot key dot get pressed, and then we will write here my key. So this is that format I was mentioning. So we will write get attribute and we will write pygame, and it has to be in this format. So it has to be k underscore, and then within the brackets it has to be the value of that key. So here we will write format key name. So what this will do is it will write it like this. So for example, if we say that our key name is, let's say, left, so it will write it like this. So this is the format that we need. So this is what we are doing. So once we have the correct format, we can now just check if key input my key, then we will write answer is equals to true, and what we will do, okay, this needs to be input, okay, and then here we will just update our pygame screen. So we will say display dot update. Now the reason I'm not going into too much detail with this code is because this is not part of the programming for drones. It is just acquiring the keystrokes. So there are multiple methods, there are multiple libraries you can use to do this. So I'm not going to go into the detail of how this works. If you want to know more, you can check out my other videos where I have explained these. So this part here, now we have created a module, and if we call in our get key function and we give in a key name, it will tell us whether it has been pressed or not. Let me format this. And what happens is that we can write a main function here to test it out. So for example, we can write main, and inside that we can write, for example, if get key. So this is how you can get the key, or let me just print it out for you first. Get key, let's say we want A, and over here I'm going to print this. So what we can do is we can write here while true run main. Okay, so basically first of all, the code will go here. It will check if this is the main file we are running. If we are doing this, yes. If that is the case, it will initialize, it will run this code, and then it will create this loop and it will keep running main again and again. So when it runs main, it will check get key A. It will do all of this processing. It will check whether it's pressed or not, and it will give us the answer back. So it will be either true or false. So let's print it out and see what happens. So if I run this is my Pygame window, and you can see now it's staying, and right now it's saying false. But if I press the A key, nothing happens. Why? Yeah, it has to be on this window. So you have to click it and then you have to press. Now you can see when I press, it actually changes to true. So this is a common mistake. Sometimes I forget as well. You have to be on this window when you press the button. So this is the idea. So here we can write, for example, if get key, let's say, is left, I think it's capital letters, left, then we can print left key pressed. Then we can write if get key is, let's say, right, then we can print right key pressed. Okay, so let's run this. So if I run it here, right now nothing is been printed. So if I press the right key, it will say right key pressed. If I press the left one, it says left key pressed. So this is how it works. So what we can do now, this is a module. So if we run it by itself, this will run over here. But we can use only this function and this function. So what we can do is, we can go to the Tello course. We can create a new file. We can go to Python, and over here, let's call it keyboard control. So here, what we can do is, we can import this module. So let me close the previous ones. So this is our module. So we can write here, import key press module as KP. So the reason we are writing it as KP is so that whenever we use it, we don't have to write the whole spelling. We can just write KP. So what we can do right now is we can write kp.init. We will initialize it. This is that init function. And then we will write kp.getKey. And let's say we want to get the key S. So we can print this out. So let's print it out. So now if I run this part, it will create that. Now the thing is, it only ran once and it gave us false. So what we have to do is we have to create a while loop if we want to run it again and again. So we will write true, and then we will put this forward, and then we can run this. There you go. So now it's saying false, and if I press the S key, it says true. So now you can see that we created that module, and we are able to use that module in other scripts as well. So, oh, the previous one is also running. Anyways, so what we will do now is we will attach this to our Tello, and we will, using these keys, we are going to move it. So let's write down the code for our Tello drone first. So we will write here from DGI TelloPy import Tello, and then we can write here from time import sleep. Okay, and then we will write here me is equals to tello, and then we will write me.connect. And of course we can check the battery. It's always good to print out the battery to know everything is working fine. Okay, so this is our initial part. Once that is done, we are going to take off. So we will write me.takeoff, and then we are going to write our code inside here. So let's remove that, and we will write here that, let's say, me.send RC control, we are going to send in 4 values. So for now we are going to put them as 0, and later on we will add something to it. Okay, so what we need to do now is we need to check if the button or the key has been pressed. If it's pressed, then we will change this values, so based on which of the keys were pressed. So we can write a function here to check the key presses. So let's call it get keyboard input, and here we are going to define our parameters. So this is left and right, then we have forwards and backwards, then we have up and down, and then we have yaw velocity, right? So we will put all of them as 0, and then we will check each one of them. So we will write if kp dot get key left, okay, it has to be capital left, then lr, which is your left right, is equals to -50. So this is a speed that we are just giving, so we can change this if we wanted. So actually we can write a variable here, speed is equals to 50. So instead of writing speed every time here, we can just write it here. So this negative means it will go towards the left side. Now if we wanted it to go towards the right, we can simply call, say, else if, and we can change this to right. Again, this has to be right, and then we can remove this. Okay, so this is how you can do for one of them, and the same thing will happen for the rest of them. So let's say this is for up and down, so we will write here up and down, and for up and down we have to use up, which is the up and down. Okay, it should not be up and down, so let's write it D over here. So here when it's going up it will be positive speed, when it's going down it will be negative speed. So this is how you can do that. And then we will write, now we are left with the forwards and backwards, and we are left with the yaw velocity. So what we can do is we can write the same thing here, copy that, paste it here. The reason I don't like to write it like this is because this is very easy to read. Now the correct method, or the standard you can say, is like this, but I like to keep it in one line if it's just one line function, one line if statement. So I like to keep it like this so that it's very easy to read what is happening. Okay, so then we will write here W and we will write here S. So we will use the WASD keys. So here we are going to use, okay, so I think up and down will be easier to be used if we are using it with forwards and backwards, because normally with up, down, left, right, we are going forward, backwards like a car. So I think it will be better if we use here forwards and backwards. And here we can use up and down. So W is up, S is down, and then we can use the A and D. So A is towards the left side and D is towards the right side. So something like that. So I'm not sure about the rotation here, which is clockwise, which is anti-clockwise. So if it's not the right one, we can switch the values here like this. So let's keep it to this, and if it's not right, we will change it later. So all of these values, yeah, I forgot to change this. This should be your velocity, and this should be your velocity as well. So all of these values are now ready, and what we can do is we can send it back, and we can write here return, and we can return all these values. So all of this will be in a single list, and what we can do is when we call this function get keyboard input, the output of this will be, let's say, values. So this will be a list, and we can just send the values of this list here. So values at 0, values at 1, values at 2, and values at 3. So this will directly send all the commands, and what we can do is we can add a sleep here just to make sure everything is stable, nothing is happening too fast. We can control this. And what else? One more thing about safety is that we should be able to land with a key press as well. So let's keep it close. So we can copy this line and we can paste it here, and instead of A we can write Q, and if we press the Q button we want to land, so we will write here me.land. So this will allow our drone to land if we press the Q button. So we could add a button for takeoff as well, but or should we add or should we not add? Let's add a button for takeoff as well. So let's copy this, and we can write here take off, and we can remove the takeoff from here, and let's say that takeoff button is E. Did we use E? No. So let's put it as E. So E will take off, Q will land, and then the rest of them will be used to move forwards and backwards. So this being done, now we can turn on our drone. I think I need to replace the battery. So let me replace the battery and let's try that out. So let's connect to Tello. It's already connected and I think it should be fine. Let's right click and run. And there we go. So it is sending the commands and the response. We have 93% battery. Okay, so I will run this now and let's see what happens.
We both were craving a quieter life, and once COVID hit, we just realized, why not?
So in the previous chapter, we had a look at how we can control the drone with a keyboard. Now in this project, we are going to create a spy drone or a surveillance drone, in which we can control using our keyboard, and whenever we require, we can take a picture of that environment and save it to our computer. So at any given time, we will be able to see where we are flying, and we can take any picture whenever we press a button. So here we can right click and create a new project. We will call this project, let's call it projects, and then we will write here keyboard control, what else should we write? Let's write image capture. It's a long name, but anyways. So this is basically our idea. First we are going to import. So we are going to import everything from our keyboard control. So this is the code that we wrote in our previous chapter. So we will copy all of that, we will close it, and we will paste it here. So over here we are going to make some changes, and what we will have to do is we have to merge these two codes, the one we did for image capture and the one we did for keyboard control. So we will go to image capture, and here you can see that we have to first of all turn on the stream. So we will copy that and we will go to our initializations, and once we connect, we will turn on the stream. Then in the while loop, we have to capture the image. So this is image is equals to get frame, and then we are resizing it, then we are displaying it. So we will copy all of this and we will go back, and in our while loop we are going to paste it. Now this is pretty much doing the same thing as this, so we are going to remove this, and here it's giving us an error because we haven't imported the OpenCV library. So we will write here import CV2. So this will import the CV2, and now we can see that if we run our drone, it will display us the image as well. So let's try that out. Okay, this is the previous one. We have to run this one. I think it disconnected. I need to connect it again. Okay, so now it's connected and we can run it. And there you go. So this is the image that we're getting from the drone. We can go back to our Pygame window, and over here if we press E, it will take off, and then I can go forward, I can go backwards, I can go left, right, up, down, I can rotate. So all of the things that we did earlier we can do again, but now we are able to see the actual footage. So this is great. So we can stop this. Now what we need to do is we need to store this image once we have pressed any button. So what we can do is we can create a new if statement here. So we can write if kp.get key, and we will write that, let's say it is the Z key. Normally it would be S for saving, but we are already using S, so we will use the Z key. So here we will write cv2.imWrite. So this is for saving the image. So now we have to save the image with a different name every time. If we don't do that, it will overwrite the previous image, and we don't want to do that. So here we are going to write a string. So we will write here, let's actually put it in the resources folder, resources, and then inside the resources we will put it in the images folder, and now we are going to give it a unique name. So how can we give it a unique name every single time? The simplest method is using the timestamp or the current time, because the date and time will never be actually the same. Even if you use maybe 1 second later, 2 seconds later, it will never be the same. So this way we can write here time.time. So this will give us a unique name every time, and then we can write .jpg. Why is it giving an error? Let's check out, because we are okay. Let's just say import time. So hopefully that error will go away. Yeah, there you go, it's gone away. And now we are getting this error, so we can write here time.sleep. Okay, so here we are getting our time, and then we are storing it as JPG. But what are we storing? We have to define that. We want to store our image. So the image that we are using here, we want to store that. So in order to use this inside this function, we have to make it global. So we will write here global image. So that should work fine. So let's run this and see what happens. So actually, before we do that, we need to create a folder here. So we will right click, we will create new directory. So our directory name should be resources. So we will write here resources, and inside resources we need to create another directory called images. So this is the directory we have to create, and once that is done, we can now run this. So again, it got disconnected. Let me connect it again. Okay, so now that it is connected, we can right click and we can run. And there we have it. So without actually running it again, we can press the Z button, and if we go to our resources and images, there you go. You can see there's a lot of images saved. And if I just right click and click on show in Explorer, there you go. So these are the images saved. Now the problem is, when I press the Z button, it clicked so many times and it saved so many times. So what you can do to avoid this is you can add a delay. So right after you press that, you will say time.sleep, and let's say for 0.3 seconds. So if I run this again,